enjoy the lengthy break. Um, Now let's welcome Ophelia on her talk on the transfer of attentional sharpening across context. Ophelia, take it away.
Hi everyone, I'm Ophelia, and today I'll be presenting a paper, like Jeremy just mentioned, transfer of attentional sharpening, and I hope you guys enjoy it. I'll just share my screen to play the video. Okay. I'm a fourth-year psychology student, and I'm currently conducting an individual project in the visual cognition lab. Today, I'll be presenting an ongoing project on attentional sharpening and how this effect can be transferred across contexts. I hope you guys enjoy it. Okay, so you might wonder what exactly is attentional sharpening. In attention research, we commonly refer to attentional template as the collection of features in working memory that represent the target of visual search. You could think of our attentional template as an imaginary field of view located somewhere in our brain, which can be flexibly adjusted according to our goals. If you want to search for University of Toronto in the world map, it isn't quite efficient, right? But if we narrow or say sharpen this FOV to Canada, the representation of Canada is shifted away from all other places. It might be easier to spot U of T now because Canada now becomes salient in our view, and everyone everywhere else in the picture becomes like the distractors. Attentional template is somewhat like this. It increases the priority of our visual attention to encode relevant features that align with our search goals. In other words, what's maintained in the attentional template will make our visual system more efficient. Attentional sharpening refers to the process by which the attentional template narrows itself to focus more on our target. And this can greatly increase our efficiency to search for the goal, which has a high target value of our interest. Gang and colleagues found that the contents of attentional template can be flexibly adjusted to increase target to distractor distinctiveness. This is what differentiates the target and the distractor. You might think when the target to distractor distinctiveness is high, our attentional system would be the most efficient because this intuitively makes sense. But as you might see from the graph on the right, overall people were getting better after the training. Again, this makes sense for trials where people need to pick out the target among low similarity distractors. But the research also found that sometimes when the target and distractors are very similar, we are still very efficient. Specifically, when increasing the presentation frequency of target similar distractors, people who encounter the most similar items more often respond faster and make relatively fewer errors compared to their performance in the training phase. Gang and colleagues explained this by the effect of attentional sharpening. They concluded that constant exposure to target similar distractors would increase pressure to sharpen our target representation. When the target representation is shifted away from distractors, the distinctiveness would be high enough for our attentional system to pick out the actual target. Gang and colleagues' research laid the groundwork for the idea of attentional template tuning as a function of target distractor similarity, but they did not tell us which system is operating behind the sharpening of attentional template that makes us more efficient in visual search. One hypothesis is that this sharpening might be due to local tuning mechanism. Wang and Gang's research provides some insights. The methods they were using were quite complicated, but the take-home message is that passively viewed colors in the training phase produce increasingly reduced interference when they are introduced as new visual search distractors. This learning during passive exposure is due to habituation mechanism. The habituation mechanism attenuates sensory responsivity to recurring stimuli. In this case, we don't spend much attentional resources on the stimuli that have occurred repeatedly, but instead focus more on selecting target relevant features. In other words, if you have seen a target color repeatedly, and when it acts as a distractor in a new visual search, it will suppress its value so that our sensory system doesn't spend much resources on it. From this perspective, we could hypothesize that attentional template narrowing and sharpening occurs through repeated exposure to visually similar distractors. As a result, people will habituate to these similar features. Through this mechanism, the target value is increased during the search, while the distractor values are suppressed. Since the target value and distractor values are specific to a certain feature, attentional sharpening is specific to that feature. Um, so if this is the case, a narrow template representation can be transferred to a new target color stimulus. For example, we might be very good at searching for a pink target among a bunch of very similar pinks, but we could not transfer this effect when we are searching for a new target color too. Wang and Gain's research suggests that attentional sharpening occurs through passive viewing of similar colors. But is it possible that it's actually controlled by us, just that we are not aware of it? Another hypothesis is that attentional sharpening is a result of proportion congruency effects. To put it simply, PC effects typically occur when people use strategic control of attention in response to conflict. This is what we call conflict adaptation or conflict monitoring. Weidler and Buck suggest that some contextual cues may trigger a flexible and automatic form of cognitive control. If this is the case, then we could hypothesize that people should be able to transfer this kind of control to untrained stimuli because we have the ability to flexibly monitor the conflict and adjust our attentional strategies according to the target-distractor similarity when we search for a target across contexts. In this current research, we want to investigate the mechanism of attentional sharpening with color stimuli. Specifically, is this sharpening due to local tuning processes, or does it reflect on the global control of conflict monitoring? Sorry. So our first step is to confirm that the transfer of attentional sharpening does occur in our experimental settings. In the experiment 1, 120 participants were recruited through Prolific. Participants were given one target color to search during both the training and the transfer phase. So training and the transfer. Depending on the version they were given, they would see either the pink or the teal. They were instructed to complete 3 epochs of training and 2 epochs of testing, where 1 epoch is 2 blocks and 160 trials. In the similar display trials, the target distractor similarity is low. For example, we could see that the target pink appears alongside 2 very similar pinks, whereas in the dissimilar display trials, the target is very distinct from the distractors. Participants were grouped into 2 based on types of displays they would see most frequently. For the training phase, the most similar, the MS group, would encounter visually similar items for 80% of the time, and visually dissimilar items for 20% of the time. And for the most dissimilar group, they would see most dissimilar items for 80% of the time and similar items for 20% of the time. During the transfer phase, both groups encounter similar and dissimilar items, both for 50% of the time. So the participants' task was to respond whether the target color is a normal or a rotated square and press the Z and M key accordingly. Their response time and response accuracy were measured. If an effect of attention sharpening occurs, we would expect that the most similar group experience increasingly reduced interference from the distractors. At this phase, we are only testing if attention sharpening will transfer when people are searching for one target color. The results show that in terms of the response time, we could see a trend that most similar group experienced less interference compared to most dissimilar groups. This effect wasn't significant, and we do see some interaction effect happening in the testing phase. And for the error rate, the most similar group experienced less interference compared to the dissimilar group. If we look at the overall pattern, the results suggest that people in the most dissimilar group will respond faster, but the most similar group, they make less errors. So would it be that people who are trying to respond faster, they are just sacrificing their accuracy, or is it the opposite? We added inverse efficiency in case there was a speed accuracy trade-off. We want to know if the most similar group is prioritizing accuracy so that they are slower at making judgments. So inverse efficiency is the response time divided by the percentage of correct responses out of all responses. In terms of the inverse efficiency, during the training phase, the most similar group experienced less interference compared to the most dissimilar group. This effect persists into the transfer phase. Because the patterns were the same as before, where the most similar group showed reduced interference, we can say that there's no speed accuracy trade-off happening here. The results in experiment 1 confirm our hypothesis, where we expect individuals to transfer their attention sharpening when they're given one target color. Next, we want to know if attention sharpening can transfer across different features. We are testing if this effect can persist when individuals are given a new target color. In experiment 2, the methods were pretty much the same as the first experiment, except that people were given a different color during the transfer phase. If they are trained with teal, then we want to see if they can transfer attention sharpening to pink. If they were given training with the pink, then they'll be tested with teal. If the attention sharpening is due to more of the global attentional control, even if they were given a different target color, we would expect that the transfer of attention sharpening persists into experiment 2. If it's due to the local tuning mechanism, then the effect would be stimulus specific, so we wouldn't see reduced interference during the transfer phase. So the results for experiment 2 showed that in terms of the response time, during the training phase, the most similar group experienced less interference, which means they were experiencing attention sharpening, but the effect wasn't significant during the transfer phase. As for the error rate for both the training and the testing phase, we did not see any significant difference between two groups to support the effect of attentional sharpening. Overall, the results suggest that people do not transfer attentional sharpening from the learned feature to unlearned feature. Even though participants in the most similar group can sharpen their attentional template when they were given pink, they did not transfer the effect for pink to the new target color, teal, or vice versa. For the inverse efficiency, The most similar group experienced reduced interference compared to the most dissimilar group, suggesting that there was no speed accuracy trade-off for the training phase. But during the transfer phase, there was no significant difference between the two groups. This may suggest that the participant did not transfer their attentional sharpening to the new target color, to the new target feature across contexts. When given a new target color, individuals' performance do not benefit from have learned the previous feature. So far, our results indicate that individuals do not transfer the effect of attention sharpening to unlearned feature. Our next step is to see if individuals were able to transfer their attention sharpening when they were given two target colors, which are the pink and teal. Essentially, we want to see if people maintaining a two target representation can successfully transfer their attention sharpening, and if one of the target color has higher priority over the other during the transferring process. In experiment 3, we want to investigate if individuals were able to transfer the effect of attention sharpening when they maintain two target color representations in their attentional template. In this case, it's the pink and the teal. And since it's still in the preliminary stage, we've collected 24 samples so far. And these participants were randomly assigned to the most similar MS group and the most dissimilar MD group. Both groups were expected to see the target appear alongside either visually similar items or dissimilar items. The color can be pink or teal for a single trial. Their task was to respond whether the target color is a normal or rotated square and press the Z key and the M key accordingly. The response time and their response accuracy were measured. There are two types of display conditions in experiment 3, biased and unbiased displays. We want to test attention sharpening when people are given biased displays and whether the effect can be transferred to the condition where they are given unbiased displays. For the biased display trials, the MS group respond to the target distractors for 40% of the time, and among visually dissimilar distractors for 10% of the time. For the unbiased display trials, both groups encounter similar and dissimilar items for 25% of the time. The biased displays correspond to the training phase in experiment 1 and 2, where the participants encountered similar stimuli 80 and 20% of the time in the one target color condition. The unbiased displays correspond to the transfer phase. Since there are two target colors, participants sees each condition 25% of the time instead of 50. Since there are more conditions in this experiment, we expect that participants won't do as good as they previously did in the first two experiments. So we changed the exclusion criteria. Originally, a participant's data would be excluded if they make errors more than 25% of the time. In experiment 3, they would be excluded if they make errors 35% of the time. So it increased by 10%. So for our preliminary results for experiment 3, for the bias displays in terms of response time and their accuracy, the MS group experienced less interference compared to the MD group. The inverse efficiency here suggests that there was no speed accuracy trade-off. And the overall results show that attention sharpening occurs for bias displays. But for the unbiased displays, they show different patterns of two groups. The most similar group experienced more interference, and there was no significant difference in the levels of interference between two groups when given unbiased displays, which suggests that no transferring of attentional sharpening is happening from the biased display condition. Individuals do not benefit from have learned the previous features. This trend is also prominent when looking at the inverse efficiency, like I just mentioned, but we still need more participants to make the actual conclusion. Overall, our results suggest that transfer of attentional sharpening is specific to stimulus. So we also added an awareness check for experiment 3 to make sure that participants are aware of the change in presentation frequency. The results showed that people would encounter similar items mostly wouldn't be able to detect the change. Because see here, they perform at the chance level. And this eliminates the possibility that people are intentionally control themselves to focus more on one specific target color. To conclude, our results suggest that transfer of attentional sharpening is specific to stimulus, which means that it's operating through the local tuning mechanism. People do not actively control themselves to intentionally sharpen their attentional template. Instead, they are habituating to the specific feature after long-term passive exposure. So thank you all so much for listening to my presentation. I hope you guys enjoyed it, and please don't hesitate to let me know if you have any questions. Thank you.
Thank you, Ophelia. Yeah, let's give her a round of virtual applause for this wonderful presentation. So I guess there is one question for you. You know, your research is very interesting, and I guess people are wondering what are further implications for further investigations in attention sharpening, like out from your research.
Yeah, just one moment. How can I go back? How can I stop share?
You can just stop sharing. Yes.
Or pause share. Okay.
Yeah.
Okay. Oh, cool. So, sorry, do you mind repeat the
yes,
question?
Absolutely. So I guess people are wondering what are implications for further investigation in attention sharpening after your research?
Yeah, so our research primarily focuses actually on the feature level of attentional sharpening, and I do think it might not be that practical for us to see or interpret this effect in our daily lives, but it actually have some implications in the in making VR and AI. So yes, I guess that's just the PhD I work with. He told me. So I'm not an expert of VR or VR or AI. So yeah, that's what I can say for now.
Right. Okay. Thank you so much. But yeah, I'll give Ophelia another round of virtual applause. And yeah, thank you all everyone for coming out to Confluence today.